Today, we're going to take a peek inside a truly world-class research group at a university in Thailand to really figure out what makes them such a global success story. All right, let's jump right in. So, what is that secret formula? Is it just about having the flashiest gear or the biggest budget? Well, as we're about to find out, the real secret sauce? It's often something much deeper and a whole lot more human. You see, the key isn't just about building a facility with four walls. It's about cultivating a living, breathing ecosystem, a place where ideas and people and pure passion can really thrive. And that brings us right here to the KMUTT Fixed Point Research Laboratory. I mean, just look at this group. You can already kind of feel that sense of community, can't you? Their success is built on a philosophy that gets it, that groundbreaking science comes from people who feel supported, challenged, and connected to each other. Okay, check this out, because this is how it all fits together. The Fixed Point Lab doesn't just exist in a bubble. No way. It's deeply woven into the university's Center of Excellence, and it works across all kinds of disciplines. We're talking physics, engineering, chemistry. And that creates this powerful feedback loop of new ideas and shared expertise. But all that structure, it's really built on something else. Let's dive into the very heart of the lab, its unique culture and its philosophy on education. And trust me, this is where things get really fascinating. Their whole operation runs on this simple but super powerful three-part philosophy. They just call it learning by. And it boils down to three core ideas: learning by training, learning by going abroad, and my personal favorite, learning by playing. So first up is learning by training. Instead of just, sitting around reading papers, they bring leading experts from all over the world right into their lab. You can see it here, from the slick graphic to the real-life classroom. This creates this intense, hands-on environment where students are learning directly from the best of the best. Second, they don't just import knowledge, they export their people. Learning by going abroad is a huge deal for them. By sending their students to conferences all over the world, they're not just presenting their own research, they're soaking up new ways of thinking and building a global network. And that brings us to learning by playing. This is brilliant. It shows they understand that the best ideas don't always happen when you're staring at a whiteboard. Whether it's a chat over dinner or just taking some time to unwind, they create an environment where creativity can strike at any moment. This quote just says it all, doesn't it? The lab's leaders get that burnout and pressure. They're the enemies of innovation. That light bulb moment needs space, it needs relaxation, and it needs those informal chats to even happen. The key here is that they intentionally build that space right into their culture. Okay, so we've seen the lab's incredible philosophy, but what are they actually working on? What's the high-level science behind all this? Let's get into their mathematical core. At the heart of it all is something called fixed point theory. Now, the best way to wrap your head around this is with a map. Imagine you take a map of your city, you crumple it up into a ball, and then you drop it on the ground somewhere inside that city. Fixed point theory proves that there will always be at least one single point on that crumpled map that is sitting directly over the exact same spot it represents in the real world. It's wild. And the lab uses this very idea to find stability in these unbelievably complex systems. Next up, you've got numerical convex analysis. Think of this as the ultimate toolkit for optimization. If you want to find the absolute best possible outcome given a set of rules, like what's the fastest delivery route for a whole fleet of trucks, or the most profitable way to invest your money, this is the math that makes it happen. And finally, they develop advanced algorithms. These are basically super-powered, step-by-step recipes that tell computers how to solve massive, messy problems. And their work here is vital for pretty much everything, from making medical images clearer to building smarter, more efficient machine learning models. So you've got this unique philosophy, and you've got some incredibly powerful science. Now for the big question, does it all actually add up? Let's take a look at the impact this lab has had over the last decade. This is the moment of truth, right? Does all this focus on culture and collaboration and, playing, does it actually translate into the hard, measurable results that say we're a world-class institution? The answer is a huge, resounding yes. I mean, just look at this chart. This isn't just steady growth. This is exponential growth. Those blue bars are the number of papers they've published, and the dark line, that's the citations. You can literally see the curve just take off after 2016. Their influence is accelerating like a rocket. Let's just pull out that one number. Get this. Since just 2017, their work has been cited by other researchers over 15,000 times. 15,835 to be exact. That is a staggering level of influence on the global scientific community. And look, it's not a fluke. It's not just one metric. Across all the major indexes, Scopus, Clarivate, ResearchGate, the numbers all tell the same story. This is elite-level stuff. And check out that note at the bottom. Top 3% author position on Scopus. That is just undeniable, verified excellence. And their influence isn't just in publications, it's in partnerships. This map shows this thriving global network they've built, with key collaborators in Japan, Taiwan, Pakistan, all across the world. They are truly doing research without borders. So where does a lab like this go from here? Well, they're definitely not resting on their laurels. They're looking ahead and they're applying their core science to solve the problems of tomorrow. They're using their deep expertise to tackle some of our biggest future challenges. We're talking about advancing quantum computing, helping out with sustainable energy, developing new tech to keep our finances secure, and pushing the absolute boundaries of high-performance computing. At the end of the day, what the KMUTT lab proves is that the future of science isn't just about technology. It's about the ecosystems we build for people to create it. So the final question is, what problem will a philosophy like this help solve next?